Welcome to the Enterprise Browser Development Fundamentals. Here, you will learn how to build rich web applications for our enterprise browser-based solutions. Finally, we get to build things ourselves. This will be a good exercise and will also allow you to recap and implement what you've just learned. You will also be able to use it as a base template for other activities. As we said before, we'll build a landing page for our web app. It will check for connectivity. If successful, navigate to the actual web server page. And if not, display a message to the user along with information that may be useful for connection troubleshooting. In the process, you will learn the following. And last but not least, how to quit the app. This is actually essential, since by default, EB runs in full screen with no controls whatsoever. We'll start with config, modifying the config.xml file from the featured demo app as described on screen. We'll disable the web server used by the demo and use the static web page instead. We'll enable the debug buttons. Having debug buttons on in the early stages of your EB journey is very important. Here is an example of a typical page not found screen. Do you see anything that indicates what page exactly is not found? Having those buttons means you can also see the URL bar and useful buttons such as reload and quit, which are disabled by default. Later, you'll see how to manipulate those buttons dynamically at runtime. We'll also disable screen rotation so it does not distract us, and set up a path to our page. Try doing it on your own. The XML is pretty self-explanatory, but if you're stuck, coming up is a short video of how it's done. Here is the config.xml that I copied from the feature demo app. We'll use it as a base for ours. Open it with an editor of your choice. First, I'll comment out the web server. Then I'll enable debug buttons. Right next, there's a logging section. We'll talk about logs in a moment. For now, let's note down the location of the log file and enable logging of informational level messages. In order to disable screen rotation, I'll just search for rotate and set it to 0. Similarly, searching for start gives me the start page. I'm using Android, so I'll set it up with the full path. On my device, TC55 with KitKat, /storage/SDcard0 is actually the internal storage, so I don't have to worry whether I have an SD card inserted or not. Okay, we're done with config, and we can put it onto the device. On my Android device, that would be internal storage data /android/com.symbol.enterprisebrowser/directory. Take a moment to examine the other files there, namely the log and the HTML files. Can you find out what they're doing? Before moving on, let's look at the logging and debugging options. This will be handy if you run into problems with exercises. EB has quite a variety of tools for local and remote troubleshooting. First, there are debug buttons, which can be set up in config or at runtime, including selective enable, disable, and repositioning. They are part of the Chrome browser, not part of DOM. Keep that in mind when they totally overlap your exit button. Check out the respective APIs, including the address bar and SIP software input panel button that allows user to bring up the virtual keypad. Then, of course, there are logs. The standard logs contain runtime information, such as page and engine errors, memory usage, but you can log your own entries as well, using either standard, the jsconsole.log open parens, close parens API, or the eb.log API that has some additional features such as categories, submitting log files, etc. With EB, you are not limited to local logging only. You can also log over HTTP to your cloud telemetry server, for example. All this goodness is configured in the config.xml, and we'll review 2 typical examples at the next slide. Next are the remote tools that allow you to debug your mobile device from the comfort of your big laptop or desktop. When running WebKit, Web Inspector is the first tool of choice, but you can also use a more advanced tool called Winery. Web Inspector Remote, pronounced Winery. Check out the detailed Launchpad guides to learn more. Here are the examples you want to follow when setting up local and remote logging. Take some time reviewing them. For remote logging, you need to use a special log receiver tool. The URL is provided here. For local logging, you want to remember that the log is cyclic. Once it hits its max size, 10 KB by default, it overwrites itself from the start. So your last log entry may be somewhere in the middle of the file. Pay attention to timestamps. Okay, let's start with the basics. Let's set up a blank HTML page and add reload and quit buttons that will double the debug button functionality, so that later we can disable debug buttons. For the quit button, you will have to use the application API reference and figure out which JS files you need to include. The reload is just a plain JS call. No EB APIs are needed. Test your page by deploying it to start location, defined in config.xml, and launching EB. If stuck, use the debug buttons. If you're seeing the Not Found page, check the address bar and the log file to see what page the EB is actually trying to open, and adjust your start page or HTML file location appropriately. One thing you'll note is that the debug buttons will largely overlap with your page. Disable those buttons in config once you have got the page working. We'll deal with them later. Try doing it yourself, and then proceed to check how we've done it. Well, this one is really simple. First, we create the standard simple HTML template with 2 buttons. Reload is straightforward. For quit, we've looked up the API reference and just executed the call. In order for this call to work, we need to include the EB API module's JS file. Let's try it. Hey, it works! But those debug buttons overlap with most of the page. There is a number of ways to deal with it. You can selectively disable them, control their position on the screen, or build your page in a way that there's no significant overlap. For now, let's quickly examine those at the bottom right, and then disable them all in config.xml. Now, let's prepare that useful troubleshooting info that we will show to the user in case of error. We need the EB System API for that. Check it out and find out how to display the values we need. They're listed on the slide. Don't do the WLAN part now, as it requires a different API. Essentially, this is a very simple JavaScript exercise. Use the body onload event to execute the JS function and populate the values. What do you replace query selector with for the old IE engine? The answer is get element by ID. It's a lot less functional, though. First, let's add all the spans to the page body that will hold the data, and an onload event. Now, let's create a function getProps that will populate all those properties. Writing all these query selector lines is a bit messy, so let's introduce a couple of helper functions. If you are familiar with jQuery, you'll quickly get them. Now we can write some nice and clean code. And if we're working with old IE Mobile Engine, we can upgrade our functions to detect that and use getElementById instead of query selector. Now, we need to hook getProps into the onload function. We will also consult the reference for the reload button and quit button API to see how to enable them. That was easy. The code seems complete, but if you run it right now, it wouldn't work. Let's carefully check the API reference for these buttons. It requires a different JS include. Let's add elements.js to the page. Now we're good. Let's load the new config, HTML, and JS files onto device, and restart EB. We had config.xml changes, remember? We need to reload the whole browser, not just the page. Look at that! Those buttons still overlap, but now it's much more tolerable. You can adjust their position if you want to. You now know the screen dimensions. Check the API reference on how to do that. Okay, on to the next step. Our next step will be to implement a connectivity check and a WLAN status information. These are implemented as asynchronous callbacks, allowing us to use an event-driven model instead of direct polling, which is energy inefficient and blocks the rest of your code execution while the polling request is being processed. Think of all the network operations for a second. You will see that a lot of EB APIs implement callbacks, so we need to be able to work with them. We will use two APIs here, Network for Connectivity Check and Signal Indicators for WLAN information. Here's an example of using the callbacks. First, you define a handler function that takes a JSON object as parameter. This is very convenient since you don't have to remember the order and number of parameters, etc. You just get an object. The specific properties of that object will be described in the API call reference for which you're building the handler. For example, here's the callback for eb.signalindicators.wlan_status, open parens, close parens, API call. As you can see, we simply output certain fields from the object here. By the way, there are more fields. Be sure to check the API reference. Now, my onload will issue the actual API call, so it will fire, process somewhere in the background, and when there's news for me, trigger the callback function. For example, on Android, the WLAN status call triggers callback whenever any WLAN parameters change, be it connectivity status or signal strength. The callback allows me to process those asynchronously. When you no longer need the callback to trigger, just issue the corresponding API stop call. We're showing you here the simplest method possible. As an alternative, check out how the very same API is invoked in the featured demo app, signal.html file, in a more elegant way that requires more code lines, though. Okay, this should be sufficient for you to build the code necessary for this step. As usual, first try yourself, then see how we've done it. First, we will add more spans to hold the WLAN and connectivity parameters. Now I'm building the WLAN status info. For this, I examined Feature Demo App and found that they used the Signal Indicators API. I looked up the API in the reference to understand what it can do. Based on this, I know now what API to call and how to build the callback handler. I start with the handler, selecting just a few fields out of many. I have also added some eye candy to the handler, so it looks nicer. Now, adding the API call to onload function with handler as parameter. I will also add a WLAN indicator icon. positioning it between the reload and quit buttons. I'm using the TC55. Your screen details may differ. Now, similarly, we'll build the connectivity check. The demo app doesn't do it, so I have to search the API reference. I find a detect connection method in the network API and learn how to use it, what parameters needed to be passed to it, and what's passed back into the callback handler. Okay, this thing needs a parameter hash, so let's build one. I'll give it an unresolvable host. Say that 1 second timeout means that the host is unreachable, and ask to repeat checks every 5 seconds. Now, let's build a simple callback handler, just like before. I'm adding a couple of variables to make the code look nice. We'll need them at the very final step anyway. Finally, adding the API call into the onload, passing the check host host and the callback function name as parameters. Okay, let's try it out. Load the page a couple of times with actual accessible and inaccessible host port parameters and see if it works as expected. You can specify host names or IP addresses there. Congratulations! We've pretty much done it. Our landing page shows all sorts of interesting info and handle callbacks. However, it's not truly a landing page. It always shows problem info. We want it to display a connecting message while checking for connectivity. On success, navigate to App Page, and only upon failure to display the details. This is pretty much a standard web development exercise with one little twist, so let's go do it. Be sure to check all the testing scenarios. First, we'll wrap our present page into a div, which is hidden by default, and show another div by default saying connecting. We'll keep the buttons outside of the divs, just in case. We'll modify the onload function so that it only checks for connectivity. The rest of the code should only be executed when there's no connectivity, so we'll move it where? Into the connectivity callback handler. You may also want to comment out the buttons and see what happens when your connectivity check successfully passes, but something tells me to keep them. Now, implement some logic in the network callback handler. That's where those extra variables become useful. The logic is simple. If we pass the check, we go to the page URL. If we fail the check, show the div and everything we used to show before. Okay, let's test it. While testing, you might see a really brief flash of connecting and then the result. Check if your results match the outcomes we show on screen. The first two scenarios are quite simple. In the third scenario, you should see the automatic change. Can you explain why? The callback is triggered every 5 seconds, so that's what happens. In the fourth scenario, you navigate to a new page and don't see the error again, so you might think that the check is canceled. If you look into the log, however, you will see that EB is still checking connectivity, but your new page doesn't have a JS function called detect connection callback, so nothing is happening. Try serving a page that has. That's why it's important to stop the checks once you're done. So here's one final modification to our callback handler. Now the logs show that the polling is stopped. It's very important to remember stopping your async requests. Otherwise, you might see unexpected behavior, memory leaks, crashes, and other unpleasant things. Congratulations! You've made it through. Check your learning via this checklist. Are you clear with everything? If you have questions, watch the video again or ask it on Launchpad. Awesome! We're almost done. Just a few final words. Now you know the basics of EB and should be confident handling more complex APIs, tutorials, and projects. But there are a few more things you want to know to be efficient. At some point, you may run into a performance issue, or what seems like one. Check these tips and definitely check out the optimization guide posted on Launchpad. Remember that generally older WM devices have less CPU and RAM, so think whether they will be able to handle WebKit at all. Should you start selectively loading modules? Do you want to keep logging always on? Or whether you can make your web app leaner in general? When in need for more knowledge or help, Launchpad is your first destination. Also, check out what you've got with the EB installation. There is a local reference. Plus, you can study some of the API source code if you are that interested. Okay, this is it. Check if you can now answer all these questions. Hold on a sec. What about the rest of objectives? What about learning scanning and other APIs? For this, we've created a number of additional tutorials on Launchpad. Now you are competent enough to tackle them at your own pace. This is it. Good luck and have fun.